Hope you all are doing great. Before we begin, let's take a moment to appreciate how many people have taken the time to share their journey, experiences, and insights with us. And today, we have someone really special. Let's welcome our very own Akash Bhaiya, an alumni of IIT Patna from the electrical department, who is currently working at Texas Instrument as an analog IC design engineer. If you have ever been curious about semiconductor design, the magic behind those tiny chips powering our devices, and what it takes to work at a global tech giant, then you are at the right place. Texas Instrument is a leader in semiconductor and embedded processing technology, and securing a role as an analog IC design engineer, there is no small feat. Akash Bhaiya has walked the same path as us, attended the same lectures, pulled all nighters for project submission, and tackled the same exam stress. Today, he's here to share his journey from IIT's Patna classroom to the cutting edge labs of Texas Instruments. Bhaiya initially started with chemical and biochemical engineering, but later switched to electrical engineering. And to keep his career opportunities open, he actively built core skills through the curriculum while developing non core skills outside of academics. With IIT Patna's strong faculty and a robust chip design industry in electrical, he naturally gravitated toward IC design. And one of the turning points in his journey was his BTech project under Casey Reiser, where he worked on hardware accelerators for neural network models in image processing. The challenge of implementing algorithms in hardware pushed him towards a career in an IC design. At Texas Instrument, he is currently working in mixed signal IC design, specifically on analog to digital converters. These ADCs play a crucial role in aerospace applications like missile tracking using radar, wearable healthcare, I don't know how many much more, and even AI powered computations by interfacing with NVIDIA's GPU to optimize power consumption. With such an inspiring journey and vast experience, we are here for an insightful session today. So, without any further ado, let's give Akash Bhaiya ahead.
Okay, thank you, Ananya. That was a wonderful introduction. So first of all, this is it's very nostalgic for me to be here, interacting with Campus Janata after a long time, and it's quite special because I've held positions of responsibilities in both SAAR and Sparkonics during my time in college, and to see you juniors carry on this culture is it's quite gratifying for me. So thank you for taking your time and being here. Uh, so I was actually asked to provide like I was told that the juniors in college are interested in this domain, in this field, and they have a lot of questions. So upfront, I'll acknowledge that there is certainly a lack of guidance, particularly for this field within the campus. I don't know how that culture has changed right now, but back when I was there was a lack of guidance. Not many people were still into this, exploring these fields. So I'm here. I want to say that I'm here to answer your questions. You can ask me whatever you want. Feel free. This is a very open session. It's not like I don't want to make it very monotonous that I keep saying something and I don't it doesn't reach you guys. So at any point you can unmute, ask me anything, interrupt me, put your questions in the live chat box or whatever, and I'll be happy to answer them for as long as you have. Okay. So, upfront, it's quite nice to see that so many people are here. I'll start with, sort of why because many of you are quite young still and, not introduced to this field and this domain. The preface of this industry is at a high right now. I'll start with the most basic, tech news. I'm pretty sure every other day you're reading on the news about some or the other, AI model, some LLM model that's being deployed, and this is certainly a technological shift. It's a big technological shift, and to support that, as someone from inside the semiconductor industry, I can tell you that this industry is ramping up very fast. We are seeing technological progress at a very fast rate, and this is sort of the right time to be in this field, because more and more computation power is needed every day in every application. It's not, I'm referring to this all these AI applications only because it's in the news and you would probably know about it already. But to support that, a lot of work in the semiconductor IC design industry is also going on. But of course you would have already heard about Nvidia and all that. I'm not here to talk about that again. But there are lots of players in the background who are working on cutting edge technology. Lots of opportunities are opening up. So for guys in first year, second year right now, if you start exploring this field right now, I can guarantee that next 2-3 years, by the time you make it out of college, you will find this career with both interesting way professionally and financially as well. So the way I started out in this industry is, as Ananya had mentioned, my first big exposure to this industry was, I had worked, my BTP was on the BTech project, for those of you who are not yet aware. It was on hardware accelerators for machine learning models used in image processing. And I had worked on it for about a year or so, right from my design lab in third year and BTP in fourth year, for about a year and a half, and under Dr. KCA. And it gave me a good perspective of sort of what is the knowledge, what is the skill that is needed, and what kind of what kind of challenges are there in this field. Basically, I mean, you talk, so many of you here must already be quite proficient with your programming skills, right? So when you talk about programming, what you see is just the front end, right? You write a piece of code and it runs and you get the result, and you're not bothered too much about how it is running and how it is processed behind in the hardware. And I was interested in that, and this BTech project gave me a good opportunity to get exposed to that. And so as she mentioned, the challenges of implementing, as she said, the challenges of implementing these algorithms in hardware and getting a real physical feel of how things function, that sort of pulled me towards this industry. Okay, so now I would like to sort of understand what are the questions that you guys have, so that we can start answering that, and go in that direction. So Ananya, can you maybe take the questions list?
Sure, Bhaiya. So we have some pre-prepared questions to start with, and then if somebody has their questions, so they can put their questions in the live chat also. So, Bhaiya, to start with the first question is, what challenges did you face while transitioning from college to the industry, and how did you overcome them?
Okay. Okay, that's a nice question to begin with. So one thing I like to put up front is, a lot of you in your first year, second year, third year, you must have already got this impression that our branch is very heavily loaded with respect to ACADS, and sort of difficult to manage. And that's true. I'm not going to deny that. You will have to do around 300 plus credits over 3-4 years. There's a design lab in third year. In our department, BTP is also taken quite strictly. You need to get output to get that 10. I can tell you that as someone who has been there. So it is a heavily loaded course, and a lot of times because of that itself, people they're not able to manage their grades well in this department. My point is, you need not correlate your grades and the work that you'll be doing in the industry. A lot of people don't look at this. A lot of people in they don't look at this industry as a career, because they feel they're not good in these subjects, or these subjects are too heavy for them. Of course, it's difficult to deal with so many subjects over 4 years, and in that somewhere people sort of they're afraid of this branch and the subjects. But that doesn't necessarily have to mean that you'll find your work difficult. Regarding the transition from so what I'm trying to say is, it doesn't matter if right now if you feel that the courses are too loaded and all that. Find your specific interest in our department is very broad. You have subjects, right, in signals, DSP, analog electronics, digital electronics. If someone is interested in control systems, and it's quite interlinked as well. Over time, if find your specific interest, and you can just pick on that and start working in that, have projects in that, That's very important to have some experience and sort of gravitate in that direction. Once you find your subfield right in the department, then things will become easy for you. You can maintain a average grade as well. It doesn't matter as long as you find your area of interest and you pursue that. Now, regarding this transition, yes, it's difficult because there is a big gap between what is taught in our curriculum. To be honest, our curriculum is outdated, particularly for EE. They are still teaching things that are quite old, and the industry has moved up far quite ahead. But one thing that you don't have to worry about if you're pursuing a career in this industry is that, right, your managers or your seniors, everybody in this field, they are all super experienced people and they are super patient because they have gone through the same sort of grind. They know that coming out of college, you're not too aware of things. You do things very, very, very theoretically. You don't have an idea of how let's say even a transistor, right, a simple transistor. You don't have a feel of how it actually works. All you know is a bunch of equations on paper. But that is not very useful in the industry actually, right? But they know that. So the first couple of years into your industry, right, you'll have a lot of learning. There'll be a steep ramp up. So all you need to do from your side is to have to just you'll find people to teach you. So have that interest, maintain that interest, find the reason why you're pursuing a career in this field. uh, Maintain a tendency towards learning, and you'll eventually get there. You don't have to worry too much about how, without knowing too much, how will I pursue a career in this field. That's you'll ramp up eventually. That's what I'm trying to say.
Bhaiya, we have a question, I guess.
Hmm. Hello, Bhaiya. I'm Ish Kapoor. I'm from third year basically. So, I am interested in analog electronics, and I have been studying it. Like, I have too much interest in it, and but I have been doing projects in digital electronics. I participated in the VLSI conference for design this contest, and I made a cryptographic accelerator kind of. For so
So
I
is it
my
you? Yeah, I think. Anyway, I think I read about that on LinkedIn or somewhere. Anyway, congratulations. I thought it was good work. Sorry to
uh,
interrupt. Continue.
So my basic main question was how can I get an job in analog electronics if I have mainly projects in digital?
Okay. There's nothing to worry about there also, because from my personal experience, as I said, I was working under Casey Racer, and he does primarily digital. As you might already know, you're in third year. And my own project was in something might be something similar to yours. It was a hardware accelerator for image processing, as I said. But but make sure that you know that companies coming to campus, what roles they would open. Not all companies that visit campus open for all roles, right? Some will open for analog, some will open for digital. So I wanted to keep both my options open. So while I was quite confident about analog on paper, in the courses and all that. And I did a couple of simple projects to keep a feel for that. And I was mainly working on digital only in my BTP as well. But eventually, when the time comes, right, uh, it doesn't matter if your experience is in analog or digital. Particularly if you're from undergraduate, they don't really look at that. You can you're lucky if the company comes for both analog and digital and you can choose to apply. But let's say you're interested in analog and only digital roles are open, you can still give the interview, get through, and you can very easily switch inside the company as well. I'm particularly in, as she said, mixed signal IC design. So I work a lot with cross teams that are working across analog and digital, and I need both analog and digital skills as well. So the most important thing is to make sure that sort of you ensure that both your skills are good, and you're gaining skills in both domains, analog and digital. And irrespective of the role that the company is coming for, right, you can get a switch inside. I can guarantee that's how it works across the industry. Getting a switch here is not difficult.
So one more question, right? So like you just said that in analog mostly the books have equations mostly, but we actually need to get a feel regarding working of the transistor and all, and equations are of no use. So are there any resources which actually explain the concept in that particular manner? Because I have been dealing with problems since an year. I am trying to understand. मतलब ऊपर ऊपर से समझ आता है. I get to know the on the but the internal working. Like for example, semiconductor physics, it's totally full of equations. Like there are like I get a somewhat feel that how the electrons are flowing and all, but still the equations are like hard to handle.
Okay, a couple of things. The first thing is to okay, so by texts, what do you mean? Which text are you referring to? I probably already know, but I want to hear it from you.
Maybe books or acha, you are asking
Yeah,
about
yeah. Which
what
books?
books I have been reading. Like
Yes.
normal books which are popular for semiconductor physics. Like I don't remember the sorry, I don't remember the author.
Ah, no, no, it's okay. See, first thing is you need not really focus on semiconductor physics. That is not, too much in when we are, doing IC design. We are not really looking at. Okay, I'll just go into a bit of detail. Sorry for those who get bored or something. You don't have to worry about the parameters of the transistor itself, like say VT or the aspect ratios, W by L, the say some parasitic capacitances or something, and how electrons move, these drift equations, all that. I've done that course as well. I think it's one of your first courses in second year, right? The first semester you
Yes,
take in core course.
yes.
But that is sort of more of a research field. That is the domain of all these TSMC people who produce PDKs. For example, I work on the 28 nanometer node in TI that is coming from TSMC. That is their job. It's their responsibility to make sure that they give us uh, a proper transistor model. So you don't have to worry too much about that. Second, don't treat this field as something that's academic. Like I'm telling this to everyone. Like he mentioned, you'll find a lot of equations, pages and pages of equations and maths in this field, but that's not going to get you anywhere. Specifically for TI also, right? If you see in the interview, what the interviewers are looking for is intuition. They give you a problem. It can be a simple to a mildly complex problem, and they look for how intuitively you can solve it. If you start writing pages and pages of equation and trying to get the answer, somewhere during the flow, you'll also lose sight of what you're doing, and the interviewer is also not looking for that. They are looking for someone who can intuitively explain circuits. It doesn't matter if see the that's the main difference between this sort of a field on paper in college and in the industry, right? Is that we do a lot of approximations. We don't rely on exact equations, and we don't write pages and pages and put in numbers and calculate exact W by L's or whatever and feed that in. We do a lot of approximations and get that to work. That's the most efficient way of doing it. So rely more on intuition. Maybe you read in your coursework in the book, you understand what the equation is trying to tell you, and develop an intuition from that and work with that. Don't always think that I should keep writing equations and deriving things from that. Okay, because you're in third year and maybe you might already know. I'll specifically address this to you. You might be calculating a lot of you have a structure. You might be calculating its output impedance or its gain. A lot of GM, GDS, these kind of terms might be fitting into the equation. You need not tell your answer right to the exact thing. You can, based on your intuition, you can they're looking for people who can apply approximations and come to a result quickly, an approximate result rather than the right result. So in that sense, right, to your question, a lot of you might be referring to Razavi or something. That's the standard text. That is a standard academic text. If you are interested in equations, use that book as a reference. But what I would suggest is, if you're looking for a more practical approach, then there's this book called Jacob Baker. He's the author, Jacob Baker. He's a very popular. He's been a very popular IC design engineer over the years. He has written a book which skips all the equations, and it tells you practically what you, not a bunch of equations that you keep writing to design something, let's say as simple as an op amp, right? So you can refer to that book if you're interested. If you're not someone who reads a lot of books like me, I don't have the patience to sit through and read books. I have not, to be very honest, I have not read Razavi completely. I have not even read Jacob Baker. If get your hands on a tool, you will learn the best by doing practically. If you have access to cadence tools, either personally or through your college lab, that's fantastic. If not, even a spice simulator will do. LT spice, H spice, whatever, anything is enough. You pick it up. My advice to all of you is, particularly those who are in second year will have a little more time than third years. Take something as simple as as an op-amp, say, right? I'm specifically telling for analog. If someone's interested in digital, we can address that too. Just take something as simple as an op-amp. For second years who are in their third semester, right, you're still not exposed to analog electronics. Analog electronics is, I think, in your fourth semester. Even then, just pick up a spice simulator and try to build a simple op-amp. It's just 5 transistors, nothing more. You can begin, even if you spend, say, an hour every day, right? Within a month, you will have a good feel of what it is that you're trying to do. Work with ideal transistor models. Don't actually try to use PDK from somewhere, like a TSMC 28 nanometer node or anything. Take an ideal transistor model, just one, and just try to bias it properly first. I think third years will have a better understanding of what I'm trying to say. Just understand how current is flowing through a transistor. If you change, say, the gate voltage, how the current is changing. These are the things that your equations describe, right? But if you look at it from the point of view of equation, pages and pages, you'll get bored. That doesn't give you intuition. Just take a simulator, just take a single transistor and get a feel for these things. If I vary for different regions of operations of the transistor, how is the transistor behaving? And once you're done with that, you can put another transistor, add another transistor, and make a simple op-amp. It's 5 transistors. It should take you a couple of weeks to do this simple project if you're putting in more time, and say maybe a month if you're putting in less time. But by the end of it, you'll start getting an intuitive feel of what this field is about. You'll slowly start moving away from equations, and you'll find a sweet spot there.
Thank you. We got my answers.
Thank you, Bhaiya. That was truly insightful. So now to begin with, the second question is, can you share your experience with internships and how they helped in securing a job at Texas Instruments?
Yeah, sure. So my internship was actually, it was when I was in the third year. So when I was in the third year, my idea was more of going into the research sort of field. So I was looking for research-oriented internships, and at that time, and we were at home as well because of the online semester and stuff. So so TCS Research and Innovation Labs, they had come in, and I had done my intern there. So I was working on it. That was more related to sort of the device physics behind the thing itself. So typically, what happens is a company like TSMC, Taiwan Semiconductor Manufacturing Corporation, they put out something called PDKs, a process development kit. It has, it's like a model. I mean, these people are the ones who are making the actual transistors, right? They're the ones who are going to fab it for you. So they have different technology nodes like 28 nanometer, 45 nanometer, 128 nanometer, and so on. But for it to fab and come out, it's going to take a long time, and you do your design in a simulator much before. So these companies also provide what is called a PDK, which is basically a computational model of the transistor, and that is what you essentially work with when you're building your design and when you give it to them. It is a very close approximation of how the actual physical transistor would behave. Right. So these transistors, they need to be modeled very accurately. All their parameters, there are so many parameters, right? In that, if they're not modeled very well, the designer who is working with it, it's going to be a disaster. When it fabs and comes out, you find that the silicon is behaving completely weird than what you had expected it to do, and it's a whole disaster. Because in our industry, things take a little bit of time. It might take anywhere between 3 to, like, from the time we give the design to TSMC, it could take anywhere between 3 to 4 months for the silicon to reach our hands, because the process, I'm sure you might know a little bit about lithography and how the pattern of silicon is etched onto the silicon, and how we get back the chips. So that's a time-taking process. So these models need to be very accurate, and I had worked on making one of these models accurate using a sort of a machine learning computational model with them as part of my research work there. Although that wasn't directly helpful much in getting a placement at TI, because, as I said, people here are not worried about semiconductor physics. That is more of a theoretical sort of subject for these sort of reasons. But it certainly helped me to get an understanding of how different aspects work within the industry. See, the semiconductor industry is very broad. You have companies like TI and say NVIDIA, Samsung Semiconductor, all these people who are designing the chips, and then there are people like TSMC who are giving these models and fabricating it for us and sending it back. So it helped me get a flow of this industry. So it helped me develop an interest. But specific to the job work that I do right now, it didn't help much.
Okay, so now, Bhaiya, this is the most asked question when we come to the second year, and that is how to start for the core domain.
Yeah, I think second year is actually a fantastic place to be in, because second year is probably the only year in this department where you can be a little free, uh, where you'll have a little bit of time. And it's the best time for you to explore whether you're interested in this field or not. See, once you reach third year and final year, you're anyway going to be busy with placements and BTP. And third year is one of the most hectic years. We have so many courses across, controls, DSP. These are very mathematically heavy courses. Some power systems courses and all. It's too rigorous. It's very scary for me to think even now. How I crossed all that time. But second year, particularly the first semester, the 4 months, it's going to be relatively, I wouldn't say chill, but chiller for you. Okay, so as I said, to explore. Um, Again, I come back to the same point. Your grades, your academics, the theory on paper, it's all only for the let's say first round. Usually your first round in these companies, that is like a written sort of test. It's online, MCQ based, um, but yeah. So it is MCQ based, but it'll be the first round, right? Is the screening round. It'll be more sort of like your mid-sem, end-sem paper, that kind of thing. So something slightly theoretical. But once you cross that and you get to the interview, people are interested in what projects you have, because that is the real experience. Like I said, that is what helps you develop intuition, and that intuition is what interviewers are looking for. Given a problem, are you able to? Doesn't matter if you reach the solution or not. Are you able to put up simple ideas that simplify the problem, so that you can move in the right direction towards getting the final answer? That's what we are interested in. So if you're in second year, I would definitely advise, whatever I told Ish, just pick up any spice simulator. If you're interested in analog, pick up any spice simulator. Just build a simple op amp. It's 5 transistors, as I said, right? Start from biasing, like how okay, what biasing means, why I need to bias a transistor in a particular operating point, what parameters are controlled if I change the biasing point, the operating point of transistors, uh, and how that affects the small signal performance of an op amp. These are things that you will anyway do as part of your course in your second semester of your second year. If you're already in the first semester or something of your second year, you can get an early start, and that will, and because you're working with a simulator and not exact equations, it won't bore you much as well. You can change parameters as you like, so just play around with it and see what result you get. And all of this you can write in your resume as part of a project that you spend so much time understanding how these things work, and that's what interviewers are looking for. If you're more interested in digital, it makes it even more easier. I'm sure a lot of you know about EDA Playground, edaplayground.com. Just open that up. It's a circuit simulator. It'll help you a mux, or a simple sort of logic. How to build your intuition about digital logic, and how you write RTL syntax online, that will give you simple projects. Start with just logic, the functionality of what you're trying to implement, and gradually move to more how to put it, more heavier things in this field. Like eventually not just the logic will matter, but how you're placing the transistors. There's a process called place and route, where it's called the synthesis process. Some of you in third year might be learning this. You can our college doesn't have a lack of tools are always available. I'm sure Casey Racer's lab, tools are always available. You can go to him and ask him to use those tools. They'll build your logic, and then go to the next step, try some synthesis, how the placement of different transistors is affecting your logic. Okay, there's something yeah, semiconductor physics is in your, yeah, correct. Okay, so you're asking at this point what you can do. uh, Yeah, so you can still do Puneet, you can still do it if you have the time for it. I think you haven't started your third year or yet, I suppose, right? So anyway, so my point is that try to build these projects, simple projects. Look, recruiters are not looking for something too big from you. All that you can come to the industry and start doing bigger projects, but the foundation, the base should be there. So if you're looking for something in analog, I would, as I said, just build a simple op amp. It's 5 transistors, no big deal. If you're interested in digital, start from simple logic projects that you can do, and then go towards place and route and see. Do if you're interested in digital, your static timing analysis is very important. Clock skews, set up hold time violations, how to fix these kind of things. Gradually, you can pick interest in that. That is something more deeper and deeper. You'll anyway do it as part of your coursework. But I'm saying, if you're interested in digital, start writing RTL. That's a very good habit. So you can explore these kind of things.
Thank you, Bhaiya. That was really insightful as I'm also in the second year, so I could say that was really useful for us. So now, Bhaiya, the next question which comes up is like when people decide their domain finally and they can see the clear path in which they have to go. Another question which comes up to their mind is what certification or additional courses like would you recommend to someone interested in analog IC design?
Okay. See, honestly, I did not do any additional certification or courses or anything of that sort. What I would tell you is a couple of things. When you're doing your coursework, right, analog electronics, or even if you're done with it, let's say, because many of you are past that stage, even if you're done with that, you might not have understood that very intuitively. So a lot of concepts might still be very confusing for you. So I'm sure you might have heard this already from somewhere, but there are lots of courses in NPTEL. If you're interested in that theoretical clarity point of view, as in you have not understood the course really well, a lot of things are still very confusing for you. It's very muddled, and you have lost track of what you learned. Your notes are not proper, that way. And if you want a quick revision, there's an NPTEL course by, look, I think everyone will recommend the one by Nagendra Krishnapura or Shanti Pavan or these people. If you already know, they are very famous professors in this field, but their courses are far too advanced. Even people in the industry, very senior, experienced designers also refer to their, you know, uh, coursework and their lectures or whatever for advice, for professional advice. But there's one, I think, by Professor Anirudhan of IIT Bombay. I think he deals with a smaller syllabus, more something that a student at undergraduate level should be able to know and answer. So you can give that course a quick revision. Particularly, it helped me a lot before the time. Actually, we were told that TA is coming on campus in a very short in duration, only 10 days or so. So in 10 days, I had to sort of revise all of my concepts for the written round. And this lecture really helped. They are freely available on YouTube. It's by Professor Anirudhan, I think, from IIT Bombay. And I think Professor Nagendra also has a more basic course, not something too advanced. But I'm saying you can find all of these courses. Just use it as a point of reference to help build your theoretical knowledge. But as such, there is no course or certification that you need to do to stand out or anything. Or if you write something in your resume, it'll show that you've done something extra or anything. There's nothing like that. If you feel that your basics are not very clear enough and you need a quick revision, the lectures by these professors will help. They're freely available on YouTube also. I mean, you can watch it on 2x or anything, and you'll still, I mean, they explain it well, so you'll be able to grasp it quickly.
Thank you, Bhaiya. Now, another question which comes up is really exciting. We really wanted to know, like, how is the work culture at Texas Instrument different from other semiconductor companies?
Uh, well, this, a lot of, once you're into the industry, right, you get to know a lot of that you're working for. Like I said, as you told in my intro, so I'm working in a So I'm working on analog to digital converters, and these products, they find use in very widespread cases. So okay, so coming to the work culture itself, right? One thing is, like I said, you need not be worried about not finding, if you feel you don't have too much knowledge or anything, that you're a newbie, you're a beginner, you don't know too much. How will I survive in this field? You need not be worried about that. Your managers, your seniors, your peers, they will all be like super experienced people at the higher. So once you get into these companies, right, in the both in software and hardware, there's this thing called a tech ladder. You might have already seen in some people's profile, member staff, whatever technical, whatever. So these people are quite experienced, and these people, they become your managers once you get into the industry. So they are patient with you. They know what sort of things to teach you at what sort of rate, what sort of workload can be given to you, what you will be able to handle, um, how much you'll be able to learn in a short amount of time. So you'll get a lot of guidance. You need not be worried about that. But yes, you need to always display that curiosity to learn. Like that is the only thing that's going to take you far. And I'm not even saying this as a general thing, that you need to be curious about something. It's not a general point, and I really mean it. You need to have that. It doesn't matter that you don't know, but it matters that you're interested in knowing, right? With that sort of an attitude, wherever you go, TI or any other semiconductor company, you'll be quite successful. You'll have a lot of learning. So that learning curve, particularly in the first 2-3 years, a lot of knowledge. For some people, it might be hard, but a couple of years, and then gradually things will start to stabilize. You'll gain more independence. You'll get an intuitive feel for the circuits that you're building, right? And once the chip comes into your hand, right, whatever you have built to see it actually, we do extensive testing in the lab. uh, there are some semiconductor standards we tested across, so for example, for people who want to know a given transistor, right, it's you can have different, okay, something we call a weak transistor, a nominal transistor, and a strong transistor, right? It's the same transistor, but based on abnormalities in the fabrication process, the the parameters of the transistors change. So we design circuits, we simulate circuits across, we call it across different corners or test cases, right? If a particular transistor doesn't behave, assuming that it doesn't behave the way I want it to behave, you need to incorporate all of those things in your design upfront, and then you need to do extensive testing for that in the lab. So, but it's always a nice experience to see your circuit actually working when it comes to the lab. And I'm not saying, I'm not here representing my company or anything. Any company you go to, you'll be genuinely happy once that silicon reaches your hand.
Thank you for sharing the insights with us, Bhaiya. Now, another question is, what tips would you give for cracking technical interview for semiconductor companies?
Yeah, so like I said, the technical interview is, so it's split into, let's say your first round is it's like a written round. It'll be mostly online, but it's more theoretical. So to prepare for that, honestly, whatever your analog electronics course is there, or your digital electronics course is there, right? Whatever you do as part of your undergraduate curriculum, that is enough. Um, uh, like when recruiters come to have, okay, there's this another thing that a lot of people ask. So there are both, people from undergraduate and people from their masters who are competing for these roles, and obviously those people know more than me. But they are more likely to be hired, and then I am not. Is that a problem? A lot of people ask. Okay, so when companies come, there is a clear distinction. They release two separate JDs, job description. Undergraduates are hired in a separate pool. The master students are hired in a separate pool. You're not competing with each other. The kind of the questions they are asked in their interviews, it's quite different from what you will be asked. You will be asked simple stuff, whatever is from your undergraduate curriculum. So you don't have to worry too much about how do I cover things that are outside my curriculum, or you don't have to do all that. Just focus on whatever is being taught. And like I said, a lot of people don't make proper notes in college. They misplace their notes. The Google Drives are all scattered. You prepare for exam and throw your notes away and you're done with it. If your situation is like that, I would strongly advise, watch these lectures, maybe even 2 weeks or 3 weeks before the company is coming, right? You can watch these lectures for a good revision. For analog, yeah, these profs are there. For digital, I'm sorry, I'm not too sure because I didn't prepare for that role. I cannot give you too much preparation resources for that. Uh, but yeah, so these lectures should be enough to prepare, to sort of revise your foundational concepts, and then beyond that, if you're interested, you can work on. Let's say I think I had done the previous year gate papers as well, just to get a exposure to doing questions, and all of this is only for the written round. You can expect the written round to be similar to gate questions or something, to that level or slightly more difficult than that. But once you get past that, right, that screening round, your interview is not going to be very numerical. They're not going to give you numerical problems to solve and get an answer or anything. They'll give you a circuit, a simple circuit, and you'll have to thoroughly analyze that. They'll change different things, different parameters, and they'll ask you, how does this respond? Now what happens? All that. So if you're intuitively strong with stuff like basic stuff like, say RC analysis, uh, first order responses, second order responses, how an amp will behave, under what cases it oscillates, these sort of things, basic things that you will cover in your second year and third year. Just be strong about it and build your confidence by revising lectures. It doesn't matter if you get your answers wrong, as long as you're able to. And another tip for many of you who might be attending interviews is always sort of think out loud. Okay, don't look at a question, don't be silent, try to get answer on your paper and just blurt out the final answer. This is irrespective of what domain, what field interview you're sitting for. You always voice out your thought process, because that's what the interviewer is looking for. Doesn't matter, as I keep saying, right? Doesn't matter if your answer is wrong. The pathway for thinking should be correct, because that displays your understanding of fundamental concepts. So yeah, just focus on the basics. Use these lectures if needed. Do practice a couple of gate papers if you need to build confidence for numericals, and do projects most importantly. That's why I say, start early, build simple projects. That's enough, and I'm sure you'll find it easier.
Yes, Bhaiya, you can ask the question.
Akash Bhaiya, hello. Am I audible?
Yeah, go ahead.
Hello Bhaiya. Myself Aricha Sharma, and I'm from third year. And I just wanted to, I am personally interested in digital VLSI. And I just wanted to know, for cracking an interview or for the preparation, how much knowledge we should have, in what proportion for both analog and digital. I know both are the fundamentals and we should be aware of both of them. But if I'm specifically focusing on digital design, then how much analog would be required? You also said for analog role, you didn't prepare much for digital. That's why.
Yeah, that's true. But but eventually now I work in mixed signal IC design. So if you're pursuing a career in this field, eventually at some point you will find that you need both analog and digital skills, because a chip it's rarely purely analog or purely digital. Right? Both components are there. There are analog components, and then there's RTL as well inside that's running, and both are interacting with each other. So both designers, both analog and digital, need to know how the other is functioning as well. A simple understanding is enough. So regarding question is what you need to know if you're sitting for digital, is it? So I think for digital, in undergraduate level, of course your logic should be strong. They'll give you sort of okay, I think if I have to give a one-line answer, eventually whatever RTL you're writing, right, once it is synthesized, your timing matters. As long as your timing, your clock skew, your setup hold time, as long as your slack, as long as these violations are not there, from a digital perspective, you're happy, you're good to go. So if you're able to get to the level where you can pick up a simple structure, like let's say, I think you might be doing adders, right? These ripple carry adders, Braun adders, these kind of topologies you might be studying in digital, if I'm not wrong. So take.
No.
Okay, you have not. Have you not yet done Casey Racer's course? I think he teaches Braun adder or something, no?
No, Sakesh, yes, I don't. Jawar sir is currently teaching us VLSI.
Oh, even the digital one, is it?
Yes, Bhaiya, Java sir is taking our digital VLSI course, and he has started with memory now. Like his research work is in memory, so he'll be teaching about memory.
Yeah, I think he had given us an SRAM project in second year or something. Yeah, so even that's good enough. Yeah, actually, if I remember my project, we had done a project with him in second year. It was some SRAM design. Yeah, that's also a simple project to begin. It's something that you can do in say 2 months or so. Uh, I think so. If you're able to uh, so you can work with things like SRAM. You can work with protocols like SPI. Okay, I'll just talk about SPI or something. Maybe some of you might not know. So SPI is like the protocol with which two chips sort of communicate with each other. Right? There is a clock. There is a data that's going out. There is a data that is coming in. There is an enable signal. These signals are asserted in different combination to mean different things. It's basically like a handshaking protocol for communication between two chips. It's very popular in the industry. Almost every chip today, irrespective of company or anything, every chip works with SPI. It is a protocol to send information into the chip and get information out of the chip, uh, e- either using another chip or say, a computer or whatever. In fact, your USB modules, right? They also have they also communicate using SPI. UART, this universal asynchronous receiver transmitter. These are simple protocols that are still very powerfully used in the industry. So you can pick up these things, write the logic for them first. Uh, SRAM design or whatever project you're interested in. These are simpler ones, SPI and UART. Write the logic for them first and ensure that it's clear to you how these protocols work, because that's very important if you're looking to pursue a purely digital design career. Companies like Samsung Semiconductor, these companies who are into memory design, companies who are into this who design this communication protocols in your PC, laptop motherboards, right? These protocols are very popular there. So these sort of companies value if you know these protocols. So implement the logic in RTL first. That itself is a good start. Knowing these protocols itself is a valuable thing, and then you can go on to things like timing analysis. If you're able to understand how to write RTL in a way that you get good timing closure, that is the perfect spot for you. If you're able to get to that level of confidence, right, you are guaranteed to be hired in a digital role. Write RTL in a way that your static timing analysis is closed. So you need to sort of work in that direction.
Thank you, Bhaiya.
Thank you, Bayo. So now with the another question we begin with. What are the growth opportunities in analog IC design and what career paths can one take after getting experience in this field?
Okay, what are the opportunities? Okay, opportunities and career paths. Okay, so opportunities are, like I said, it's widespread. There is no lack of chips today. It's one of the first things you can tell to motivate yourself to pick a career, to start a career in this field is there is no lack. Like I said, all these computational models, every single day they release a new model, right? So the amount of computation that needs to be done, the amount of power that needs to be supplied is just exponentially increasing, whether it is in your AI field or whether it is, let's say, in an automotive field. Automotive field is not something that a lot of you might be knowing, because these things happen in the background. Let's say, for example, right, this Flipkart, Amazon, they have their warehouses, but they employ very few people. So how do you think these machines are functioning inside? They have machines to sort delivery packages based on what location it needs to reach and so on. So all these things, there is some chip that is running some computation, some logic that is eventually powering all of this. And this automotive industry is a huge industry. It's one of the biggest demanders of chips in a way. And then you have automobile industry as well. For example, my team supplies to Tesla. We supply clocking chips to Tesla. um, So and Tesla, I think they're entering into the Indian market as well, right? Based on the recent news. So you'll have more local opportunities in chip design. More companies are going to be hiring locally to satisfy these manufacturers' needs. So that the opportunity that way is there in every field. There are tons of products. If you're, for example, ADCs, right? I work on ADCs. It is more towards a logic side. If you're someone who doesn't like logic too much and you're interested in a lot of like only pure analog, a lot of power supply, satisfying power demands. Let's say, for example, right, Nvidia has this problem. They are burning huge amounts of power. I think some of you might have seen their CEO unveiled a chip that can this huge chip that can process the entire internet's bandwidth, right? The amount of information it has. Where do you think is going to the power for that is going to come from? I'm not even joking when I say that these chips, they consume so much power density that if you don't optimize power consumption, right, that they will literally melt in your hands once it comes to the lab, and once you switch on the power supply, it can literally melt in your hands. It's that bad, and we are working at very fast rates. Like for example, 64 gigasamples. The power supply, the dissipation, the logic, all of this needs to be processed at rates that you cannot even possibly think about. Like 8 gigasamples, 64 gigasamples. That's like 125 picoseconds. Just try to imagine logic that's being processed at 125 picoseconds, 62 picoseconds, and so on, right? You barely have time to do anything, and your chip needs to finish its function within that time. But still, but we are producing chips that are capable of doing all these things. So the demand, the career opportunity, the growth, the learning will always be there. And regarding opportunities, once you reach here, there are mainly three pathways that you can pursue. One is you keep going deeper and deeper into the field. That's who we call a technical expert. You gain more and more knowledge, and you become these people are called technologists. Eventually, say 20 years down the line, once you become quite experienced, these are the people who will drive what sort of parts you make, where these parts will end up. Um, they sort of come up with innovative ideas on how these chips should function, and these people are technically very strong. Other people, you can also choose to branch out and pursue a more diverse role. Somebody was asking, like I was telling somebody, right, you can enter into an analog role into any company, spend a couple of years there, and decide that no, you're more interested in digital now. You may branch out to digital, work with RTL and logic for a couple of years, and now you say that I'm more interested in not exactly IC design, but I'm more interested in how these chips are being used by customers in their system. So you can become a systems engineer. You will have a broader understanding perspective of how different industries and companies are using your chips. Or you can choose to become like a pursue a managerial role. You don't have to particularly in the engineering field, irrespective of whether it's software or hardware, people who step out to do an MBA and then come back, right, they are not valued as much than people who have stayed in a technological role for many years and then they are transitioning towards a managerial role, right? So if you're someone who's interested in pursuing uh, this business management, product management in the future, you have opportunities for that as well. 5-6 years into the industry, you'll figure these things out.
Thank you for shedding the light on this topic for us, Priya. Now, another question is, what are the key skills required to excel in analog IC design?
Key skill. See, I would really go back to the same point. Uh, your base needs to be okay. I wouldn't even say strong. If you're reasonably confident on your base, uh, okay. For example, imagine this flow. Let's say you watch those lectures, right? And you're not going too much into detail as well. Whatever is covered in your undergraduate curriculum, to the extent, draw a boundary and say that that is my syllabus. And to that extent, if you're confident with the basics, right, you need not sit and do tons and tons of numericals and fill pages trying to solve problems. That's not necessary. An intuitive understanding of the concepts is enough. If you have that, uh, people here in the industry, they will teach you. You need to you The most important thing, right, you need to exhibit is technical skill your ability to grasp information is that's what people are looking for. If they teach you something, are you able to quickly ramp on it? And that will come only if you have a good intuitive understanding of the very basics, very fundamentals, and whatever suits you best. It might be a book, a text, or some professor's video lectures, or some online resource. Actually, this I think UC Berkeley, they have a very good EE department. UC Berkeley and Texas A&M University, TAMU, right? You'll find a lot of their resources online. Their profs, they publish their material. There is MIT OpenCourseware. So there is no lack of material for you to build your basics. Refer to these, build your basics from here, and that should be enough. Eventually, you will learn things once you're in the industry, in how it is actually done.
Thank you, Babe. Now, another question is did you consider pursuing higher studies or was industry experience always your goal?
Uh, I actually did because, see, again, I was in college. I was someone who I kept all opportunities open, so I was exploring everything. I had done a decent amount of work with the hardware accelerator, so I was looking to pursue higher studies in a more research oriented field, in that specific domain. But apart from that, but as I said, this particular industry, right? If you are specifically looking to go into chip design, I would say industry is a better spot to be, because like every year, or every half a year or something, technology keeps changing, and you'll get a first-hand feel of working on these things. Whereas if you're in research, things are a little more slower. But because I was working on my BTP for a long time, design lab and BTP, right, a year and a half, so I was keeping that option also open. But it's just that TA happened to come, and I happened to get in before that. But if you're someone who's if you're pursuing a project, let's say with a prof, so once in your second year or third year, right, before your design lab, at least make sure that you have worked on some simple project by yourself, and then you approach. Anyway, in design lab, you'll be distributed between professors, right? If you're purely interested in research, more mathematics, you can choose someone from the signals panel. I don't even know which profs are still there in our department, but you'll have a signals panel, right? That is, they do a lot of good work as well. They are more prone to publishing papers. So if you're looking to go into the research field, I would suggest exploring signals panel, doing a project there in your design and BTP. And many people from my batch and my juniors as well, they could get into good universities, good research programs based on what they did there. If you're looking for industry exposure, you can work with I think BK Tiwari sir should be there, Java sir should be there, KC sir should be there. All these people, but it's just that before your design lab, you can decide what it is that you want to do, and make sure that your design lab project and your BTP is more oriented towards what you want to do. Because after spending a year and a half in design lab and BTP, if you decide that this whatever I did is not at all going to help me, in future once I get out of college, that's not a very ideal thing. So, by the way, where are you guys with respect to like your design lab and BTP? Has it already started, or?
Yes, we just started. I'm working under KCRI, sir.
Okay, so hopefully you guys made a choice based on what it is that you want to do. But no, all I'm trying to say is make your experience in your design lab, and because it's half a semester and then 2 semesters, right? It counts for a lot, and the work you do here will, at least at a personal level, it will teach you a lot. So make sure you're putting in your your effort and time into learning something that might help you in your career. If you're not at all interested in what you're doing, let's say you took your design lab and you're not at all interested in what you're doing, you can change it in your BTP. Nobody will force you to work with the same person that you're working, same prof that you worked in with in your design lab. So use that half semester to judge whether you like what you're working on or not, and then sort of try to change into something. Ask people from other panels. don't do it purely based on grades. Okay, I know a lot of my batchmates as well who did it purely for grades. This panel, this prof will easily give a 10, take this, not too much work. That is true. I'll tell you, there are some panels that are relatively easier than others. So if you're purely looking for grades alone, make your choice based on that. But if you're genuinely interested in pursuing a career, either research or in the industry, in this field, in any subfield of E, right, use your design lab and your BTP very well.
Okay, so seeing the question so far, I could definitely say there is a lot of curiosity and interest in this field, Bhaiya. And we are really grateful for your expertise and for answering our questions. Now, if anyone you have question, just raise your hands in the chat box. We will get the mic to you.
Hello, am I audible?
Yeah.
Apart from career, we have some fun question related to you. First is that what is the weirdest or funniest thing that has happened to you at work?
Weirdest or funniest thing? Actually, this is something that I tell a lot of people at parties or something when you first, as an icebreaker or something, right? That like people actually mistook me for somebody else. So like some other person was supposed to join in my team as well along with me, and he didn't end up joining. And for the first couple of weeks or so, my manager assumed that I was that person, and and he was far more experienced. He's supposed to be experienced, so she was like giving me tasks that were way out of my level, way out of my knowledge, and I was also a new entrant, right? So I thought the jump from college to work is too huge. Right at the first week of work, I'm being given such difficult tasks. But it was a case of sort of mistaken identity, and she was thinking I was somebody else for a very long time, and so that that sort of scared me for a while because the work I was being given was so difficult back then for me. So, like it was a case of mistaken identity.
So like when she came to know about your real identity, how did she react? And
Yeah, no, she was. I mean, she was quite. That is the thing is I've seen people at their levels, right? This is irrespective of industry. These people are heavily overworked, to be honest. They barely have time to keep track of because these are sort of technology leaders. They have so much things to worry about in their mind. So, and it's a common occurrence. It can happen to you in this field, in any other field, right? Your super manager, the team's super manager, right? The main leader. They It's difficult for them to focus attention on every individual person that way because they're just super busy. So these kind of things keep happening. But it's a good thing if you're getting to interact with people irrespective of industry, right? When you enter the workforce, make sure that your learning doesn't stop. Um, to be real about it, right? There are also teams that don't do much, lot of work. It's possible for you to end up in a team like that as well. You're not learning too much. Your team is not producing too much output. Things are moving at a very slow pace. It will bore you over time, and it will make you sort of feel very very bad about yourself, your career, the place where you are in your career. So and you can always ask for a team switch when those kind of things happen. Wherever you are, right? Make sure your learning doesn't stop. That's the one thing I would like to say for your career growth.
Do anyone else has to ask any question?
Okay, Saksham has asked embedded systems, its scope, and what concepts it includes to study. Okay, yeah. So for embedded systems, hmm, I mean, scope wise side, it's always there. It's not going anywhere. So if you're interested in like if the concepts in that field interest you, then you should certainly pursue it. But by embedded systems, I mean it's very broad. You can have anything ranging from Okay, regarding scope, I'll tell you something. Let's say the ADCs that we make, right? This is a very personal experience. I am telling from that. Um, there is only a certain level of accuracy that okay, let's say simply put, right? You want an ADC to be very linear. If you give a linear input, right, to the ADC, you want it to give an estimate in digital that is also moving linearly. Uh, it should not introduce any non-linearity of its own, because then if you're going to give it some x information, you end up getting some, x square, x cube, some other information, right? You're not interested in all that, and that's wrong. But practically, it's very difficult to make a very linear ADC, because inherently, right, your transistors, right now, for example, right, your transistor, the current equation of your transistor itself is non-linear. It's a square law, right? So you cannot get fundamentally, you cannot get a linear performance from this kind of a system. So, but we cannot give a non-linear product to a customer and say, use it. This is what we can do. That's very bad for them. So its performance needs to be corrected. If I give a linear input, I get a non-linear output, and I need to correct its performance. These sort of corrections, right, they are done in embedded systems. So typically within these chips, almost every chip today has a processor sitting inside. It's a RISC-V processor that's sitting inside, which is running something that we call a firmware. So if you're someone who's interested in writing firmware, you want to get a real feel for how your code is run. Let's say you're not interested in pure RTL, or you're not interested in pure analog, but you're interested in controlling chips and how they behave, how they interact with other chips. These sort of things are usually done in firmware. Whatever is not perfectly achievable from transistors, from silicon, it is corrected. There is a processor sitting inside the chip that runs it's typically a C program. A C program is flashed into that. It interacts with different parts of the chip, and it gives us information. Um, so if you like to code, let's say, but I'm not referring to typically the C code that you might write on your system. So far, you might be used to writing. That's not the way code is written in hardware. You cannot run the same software code on hardware, because it's not very efficient. It's not optimized. So if you're interested in how a processor processes code, right, how it infers code and how it takes information from that, and how to write code that is optimized for at chip level, at same even machine language level, and these kind of things, you can choose to pursue a career in firmware. There's a lot of opportunity for that. Like I said, every chip, right, whatever error it is making is corrected by this firmware. So you'll find a lot of opportunities for it. And what you should learn for it is, basically improve your operating system is very important, because these chips are, typically the processor which has an operating system, and which is then running a hardware level C code on top of it. So how these things interact, how your code works with an operating system, computer architecture, these kind of things is what you should look to learn. That will be useful.
Any other questions? Okay.
Ratio of people who work in digital domain in TI out of total number of employees. Uh, the ratio is actually pretty good. See, because you might be hearing, right, even the way TI advertises itself is like, we are an analog and embedded processing company, right? But that doesn't mean there are only digital engineers. Like I said, I work in a mixed signal group. My group, for example, has almost a 1:1 ratio, because like I said, this is very important. This is where the demand is coming from. Even if something is a purely analog chip, see, getting performance in analog is very difficult, because it's a real transistor model, right? It's a big headache. Things are very nonlinear. Things consume a lot of power, and anything can go wrong. So these sort of things are fixed in firmware, in digital, using RTL. So these days, right, almost everything is slowly becoming mixed signal. inside your chip you have like two boundaries. There is one analog boundary, there is one digital boundary that's interfacing with each other. So every chip, although we say that it's a predominantly analog chip, it's a or something, right? There is equal digital work going on in there, and one cannot function without the other. So specific to TI, the ratio is almost 1:1 in my team. If you take some other things like embedded processing, right? The TI also makes processors for industrial automation. They're actually quite popular. You can search for them. They're called Sitara microcontroller units. This team is almost it's very digital heavy. Those guys have the main role there in digital, and analog just does power supply sort of work, minimal work there. So if you're looking specifically to apply to TI for a digital role, I would still encourage you.
Thank you, Bhaiya. So anyone else has the question?
Just a minute. He also asked what you should include in your resume to apply for TI in digital domain. Priyanshu, there's nothing specific for TI that see, whatever you're going to include in your resume to apply to any other digital company, right? The same thing you include here, because fundamentally the what you need to be good at is like I was telling somebody, right? If you're able to write RTL code that gives you good timing performance, good static timing performance, right? That is all you need to put in your resume. With that, whatever projects you've done in that direction, right? You send your resume to every digital company there is, I'm sure you will find good roles there. Yeah.
Yeah, you can ask the question.
Hello, am I audible, Bhaiya?
Yeah.
Hi, Bhaiya. I am Udit Sharma, and I'm in second year currently. For me, actually, my dream companies is Intel, like AMD and Qualcomm. So I eventually want to end up there. If I have chosen to be in core, and the reason for this is I want to end up in these companies. And how should I know? Like, I see the roles and requirements. They usually hire students which have MTech degree or which have higher education. But how should I ensure that during that my BTech curriculum is suffice to make me eventually end up in those companies for those roles? Is it possible?
Yeah, it's certainly possible. See, again, there is this, maybe it's a more college specific thing. There's a perception that semiconductor companies are hiring only master students. That's actually not true. They have a separate pool. Like I said, when they visit campuses, there is a separate job description for undergraduates, a separate job description for master's people. The pay scales are also different, and once you get in, right, what you're expected to do is also different. So it's as an undergraduate student, it's completely possible for you to still get there. So like I don't know what specific kind of role that you're targeting. No, what was your question again? If you're asking if it's possible, then yes. But I was saying, I was talking to someone from a lot of people from your campus placement team as well. That historically our college, it's still on the lower side. The number of companies that visit, right, still on the lower side. It needs to be higher. And first is we need to sort of bring in more companies that way. So then then those roles for undergraduate students will also open up. It's not that these companies are not hiring at undergraduate level. They are. If it's not coming to campus, you can always apply off campus. There are lots of roles, I'm sure you would have seen, where they say that it's specifically tailored towards undergraduates, where they say that your experience is 0 to 2 years. You can apply in those roles. 0 to 1 year, 0 to 2 years. You can apply in those roles off campus if companies are not visiting campus, and you will seriously be considered. They won't reject you because you're an undergraduate student, because each of these companies, they need both kind of students to perform, both kind of employees rather, to perform different roles. So you can still end up there. And if you're willing to go the distance, right, like for example, I mean, you mentioned AMD, so I'm assuming that you're slightly more interested towards digital side. Static timing analysis in itself is covered at a slightly simpler level only in undergraduate. If you're willing to go the distance, uh, maybe you can learn from some online resource or approach specific professors to give you more material that you can prepare. And if you're able to put in that, I mean, if you've anyway decided to pursue a career in this field, if you're willing to put that small effort into bridging that gap, to be honest, right, even in master's courses, pretty much first year or something is spent in revising stuff at undergraduate level. So there is not a huge difference. I see people, I work with all sorts of people, right? There's not a huge amount of difference. It's not like it gives you a big disadvantage because you're undergraduate. If you're willing to put in that extra effort and cover, let's say, some advanced concepts of static dynamic analysis, how to write functional RTL that is power efficient. I think in your final year you will have a lot of elective courses, right? Okay, I think you guys are third years. In your final year, there is, I think, a course called, somebody offers low power VLSI design, I think, that you will be, anyway, your elective courses you will be doing with masters guys. So you're learning things from there as well. If you're able to ramp up on those concepts well within time for your placement, right? Eventually you're bridging that gap between you and master student. There's not a lot of difference. And if you have a project, that is the most important thing. You need to have a project, because that demonstrates that your advanced let's say static timing skills, right? They are not only on paper. You've actually done it and you have shown it. You have understood by doing. That will give you a huge edge, even if you're competing with the master students. You're in third year,
Yeah.
is it?
Thank you.
Yeah,
Yes,
no, I
Bhaiya.
just wanted to finish by.
Yeah, I'm in second
So
year.
you're
Mhm.
Oh, you're in second year. That's even fantastic. So you have, that's why I was saying, you use your design lab and PTP very well. See, 1.5 years of, if you're putting effort into 1.5 years, right, you can do a lot of work there. And if you've decided to pursue your career in this field, approach the specific prof that you're interested for whatever specific domain. But I think AC Racer might be a good fit for you, because he typically gives out these hardware accelerator kind of projects. At least he used to during my time. And these kind of things are AMD. Companies like AMD are working on this across so many teams. So 1.5 years of working on something like this will give you a clear cut advantage over any theoretical master's course or whatever.
Yes, Bhaiya. Thank you very much, Bhaiya.
Uh, Hello, Bhaiya. I did love to know about your time in the Sparkonics Club. When you were a member of Sparkonics, what activities, projects, or initiatives were going on? How the club functioning those time?
See, actually, when I was there, pretty much nothing was happening, and I shouldn't be saying this because I was the subcard for this club. When I was in college, and back then not a lot used to happen. But I think now it's I see you guys are organizing these kind of things. There's a lot of interest in it. Uh, Most importantly, the campus culture, the student culture should be built over time towards uh, you know events that Sparkonics is doing as well. Do you still have this static rush or something in Celesta or whatever? The Sparkonics Club used to conduct that during my time, and that was the only thing we did. It's participate in Celesta or whatever. Oh, you don't? Is it? That is also sad. But yeah, I think the club has grown a lot since I have come out of college. That's a good thing to see. I would encourage all these subcords or cords, whoever are there, to reach out to. I think some of my seniors are. One of my seniors, I think you might know, Azam Mohammed Azam Bhai. If somebody knows, you can reach out to him. He's in NVIDIA. He's doing good work there. A lot of people went to do their masters, so they're in research fields as well. My own peer, Anuj, I think he's in EPFL in Switzerland, doing his PhD in one of the signal fields. So a lot of people from my batch, from my seniors, they are doing a lot of things in this field. So reach out to them, get them to do these kind of sessions. Uh, you can reach out to us for particularly the first year, second years, right? You can don't feel hesitant to reach out to anybody to ask for guidance or referrals, particularly. You know, you might be sending a lot of these cold mails, right, to profs for research interns. Your industry also works similar. You look at an opportunity, internship opportunity, anywhere on LinkedIn, just apply blindly. Doesn't matter. It says you need 2 years experience, but doesn't matter. Just apply and try to get a referral. You'll find somebody from my batch or my senior batch working in one of these companies. Get a referral, and I think you'll be able to, that'll give you a breakthrough into the industry. So don't hesitate to reach out to your seniors.
Thank you, Bhaiya.
Okay, we have one more question there.
Okay, so regarding projects, right, Puneet, that's why I said, if you're doing a project on your own, like I am sorry I keep giving the same example, but that's the simplest thing I can think of. Just take an op amp. Uh, it's one of the first things you learn even in your analog course within the first, I think, 1 month to, at least before midsem it is covered, right? So you can work with it independently on your own level. And it's not too complex. Even if you have no idea where to begin, you'll find tons of resources online, tons of YouTube videos that explain step by step, right, how to start, what kind of things you need to look at, what sort of things are important to start in the beginning phase, what is important in this project, in the middle, how you should cover towards the end. So they give you sort of a stepwise plan, right, on and they guide you on how to do it. If it's only an op amp, it's quite simple enough. You can make your own plan. Let's say, first I'll assume that it is biased properly. I'm not going to worry about that, and I'll just look at the AC performance, what I'm getting. If I change parameters of different transistors, how my AC performance is changing or whatever. Once I'm done with that, I want to explore some biasing schemes, why I should bias transistors, how I should bias transistors. These are things you can do for yourself on your own pace. You don't need too much guidance because it's just playing around. You're just trying to get an intuitive feel. Once you're past that stage, right, then my advice is to go to a prof. That's why I keep saying, use your 1.5 years of your design lab and BTP well. Go to a prof and they will properly guide you through it. I don't know how you feel about profs in our department, but a lot of them, they're quite knowledgeable. They do a lot of good work. A lot of them have good PhD students under them as well. So, go to them. They'll guide you through it, on how to approach more complex things in the project. And for digital, right, let's say you start with, like I said, an SPI protocol or a UART protocol. These are things you learn in your digital electronics course in your third year, at least fundamentally, very basic. And even if you haven't learned, you just Google it. It's maybe you'll get a one-page description of how a SPI or a UART module should behave. And if you're confident in RTL, just try to implement it. You can get a simple start from there. Then for more complex things like, say, hardware accelerators or whatever, do a design lab project.
Yes, Bhaiya, you can ask the question.
Actually, Bhaiya, how can we improve our relationship with Texas Instrument as it has been bad since last year?
Yeah, I was recently made aware of this issue. I think Ariche he is contacting me at. I've actually spoken to. Whatever I could do, I've spoken to my hiring manager. Uh, the these campus formalities have not started as of yet, but because right now it's in. I think Ariche was trying to reach out to some bunch of people, and you didn't get a proper response or something of that sort. Because right now it's still early, right? Right now the internship season just got over. The internship hires, so campus placements are yet to begin, and that process it'll take a while to start. So at that time things should get more active. It will help that I am there. So when you guys do start calling other companies, right, you can reach out to me again and I'll go talk to my hiring managers. But yeah, but this is something that can be worked on. It can be improved. From your side, another thing is you need to make sure that the student culture as well is, start working on simple projects. You need to give motivation. you need to give motivation to the company to come to visit, right? They should know that the student pool here is doing some work, that it's worth hiring for them to come here and hire. So that itself is a very strong reason. Um, and so far, all these years, it used to happen that way year after year. But now, for some reason, some reasons, they're not coming. But I would still advise, let that not change any of your plans, right? The HR team from TI and your placement teams can always make that happen.
Okay, yeah, thank you.
Bhaiya, we have one more question in the chat box.
Working in a domain related to signal processing. Signal processing. Signal processing is more of a research oriented field, as far as I know. And in my batch, there's only one of my batchmates, Anuj. Right, I'm your Sparkonics coordinator who can reach out to me. I'll give you his profile. You can approach him. He did some great work in research, and he's working in cryptography right now. Cryptography is also a form of signal processing. You'll have an elective course in your fourth year. I forgot what it's called. It's offered by Preetham Kumar sir. It has to do with all these 5G codes, like how error coding is done in your 5G systems, 6G systems, and all of that. He's working in a similar domain in specific to cryptography, signal processing and cryptography. He's doing his PhD in EPFL, Switzerland. I think he can give. Like right from second year, he's done a research internship in France as well in second year itself. So you can approach him. He'll give you good guidance on people who are interested in pursuing research.
Do anyone have any other question? Can raise your hand. Okay, I think Bhaiya, it's over for now. So a huge thank you to everyone for your enthusiastic participation in today's session. Your insightful and thought-provoking questions truly made the discussion engaging and interactive. And now, Akash Bhaiya, if you give the consent, we can have some quick nostalgic rapid-fire questions with you.
Yeah, sure.
Okay. So the first question to start with, do you still secretly flex that you know both chemical reactions and circuit reactions?
To be very honest, I don't know either. I didn't learn anything in chemical after first year, and I'm still learning circuits, and I wouldn't say I'm too good at that as well. So I'm still learning. I don't know either.
Okay, cool. Another one is, what is the one electrical lab experiment at IIT Patna that made you question all your life choices?
I think the electrical systems lab, the one behind the workshops, they are very, I think, rigorous. I mean, on a fun note, I think a lot of you will this question, right?
Agree, Bhaiya. Definitely.
In every course, every lecture, every lab, at some point you'll be sitting there thinking, why you're forcing yourself through this. But that's part and parcel of the coursework. There's nothing much you can do. But it's fun as well. We have burnt lots of chips in digital, the lab, whatever lab you have, a digital and analog lab. We have burnt lots of chips. I think somebody has burnt stuff in the electrical lab itself. One of our seniors. That's why the shoes were. I think our rubber shoes are still mandated, right, in that lab.
Yes, Bhaiya.
Yeah, that was the reason somebody burnt everything and threw a shock or whatever. So it's fun as well.
Okay. Yeah, we also did something, so it's fine. Okay, another one is, if your brand changing story were a Bollywood movie, what would its title be?
Huh. Mm. Well, I honestly don't know how to answer that. I think Are there any terms for? Oh, there's a fun fact. I was the last person to get in through the branch changing list. So it's a play on fate as well. There was every possibility that I might not have made it into the branch changing list as well because I was the last person in. So whatever movie is something that happens. Maybe you can keep that as a title.
Cool, Bhaiya. Okay, another one. If you could relive one day from your college life, which one would it be?
I think it would relive, huh? A lot of good moments, but I think leaving college on the last day and seeing off your friends. I was actually the last one to leave from campus. So that is, I think that'll always be a very emotional moment for a lot of you. A lot of you are yet to get there. Because I'll honestly tell you, you'll leave college and you won't see a lot of people. You'll be in the same city. Most of you will probably end up in Bangalore or Hyderabad if you're pursuing a career in industry. But your friends will drift apart. That's kind of sad. But so it'll always be more memorable for you. The last time all of you are together as a group.
Indeed, Bhaiya. Another one. Which professor's lecture was the hardest to sit through, like without dozing off?
Uh, I'm honestly, I was your typical first bench student, so I couldn't doze off sitting in the first bench. I liked everybody's lecture. Not that I was very studious or anything, but I genuinely liked the subjects. So be sitting in the first bench, you can't sleep, and many profs, I think particularly, I think Yatendra sir, these people, they hate if you sit in the first bench and sleep, right? So I couldn't afford to doze off that way. So,
Okay. Okay, which professor do you think would make the best stand-up comedian?
um, I think Ali sir he's still there, right? He was the most. I think he had a fantastic relationship with students. He used to be, you sleep around in his class. He didn't mind. He used to joke about it. He used to joke about attendance and stuff. His exam papers were very hard, and people used to score in single digits and stuff. And he used to make jokes about that as well. So he's the most. At least during our time, he was the funniest prof.
To be honest, we didn't found him to be very comedy type, but yeah, for us too, he was very strict. But yeah, he's a good
Oh, really?
professor, definitely. Okay, last one. If you could time travel back to your college day, which year you want to go and why?
Probably second year or something, because second year before March 2020 or something, because after that things shut off for us and we had to do everything from home, and that was a weird experience for us. We have also had our fair share of have you guys had online exams or whatever, and I know I shouldn't be saying stuff like this, but we have done all that copying with the camera on and phone and lecture notes below the camera screen and stuff like that. So I don't know if you guys will relate to those kind of experiences, but because that was online, it was not a great thing. I'd like to go back to a time when we were still in college. So that was second year for me.
We never got the chance to get things to do this online, but yeah, sometimes we also did. Although it is almost impossible to do in the electrical professors under electrical professor guidance, but okay. Okay, so that
Oh,
was
has
really.
anyone already been caught for
Huh?
cheating or whatever? Because every batch there is one person who gets caught for cheating in your actual exams, in midsems or endsems, and then he's banned from that course or something. That happens every year in our department. Has it already happened in yours?
This time, no. Okay, well, that was really fun having you. So, all right. As much we would love to keep this going, Bhaiya, but of course we have to keep your time also in our mind. So we do have to wrap up. But before we do, let's take a moment to truly appreciate Akash Bhaiya for sharing his journey, insights, and experience with us. Bhaiya, thank you so much for taking time out of your schedule to be here. Your guidance is invaluable truly, and I'm sure many of us are leaving this session today with a newfound inspiration. And to everyone here, remember your journey doesn't end in the classroom. The knowledge you gain today can shape your future in ways you can't even imagine. So keep learning, keep exploring, and who knows, maybe one day one of you will be back here standing where Akash Bhaiya is today. So with that, we wrap up today's session, Bhaiya. Thank you everyone for being such a great audience. And thank you, Akash Bhaiya, once again.
Yeah, thank you for having me. And I'd just like to end by saying that, as I said, don't hesitate to reach out to your seniors. We are always available. You can reach out to me on LinkedIn or mail or whatever. In any form, you need a referral or you need a guidance on how to sort of orient your CV towards specific roles in companies or whatever. I'm always there. You can reach out to me for whatever. And yeah, thank you. This has been a great experience for me as well, and Ananya as well. You've been a wonderful host. So kudos to you on that.
Thank you so much, Bhaiya. That means a lot.